Wow, that bug looks like it's walking on the water.
Of course! It's a water strider.
A water strider walks on water?
Yeah. Water has a surface membrane created by cohesion that is strong enough to support a water strider's weight.
Wow! Maybe Jesus used a surface membrane too.
I doubt it.
How can an insect walk on water? In a body of water, where is the strongest cohesion found? How can we break surface tension? Let's find out.
Hi there, and welcome to Moonkong's Simple Science. Have you ever gone fishing on a lake and you look around and you notice there are little bugs sitting or walking on the surface of the lake? How are they doing this? Are they performing a magical feat? No. They're just taking advantage of surface tension and water cohesion. If you're confused by that, don't worry. I'll explain it in the next few experiments. So in experiment 1, I have 2 glasses and I have water, and I'll submerge both of these glasses into the water. So I will fill both of them up completely. All right, and then I will put them into this container. And you can see that the water from the top cup is being completely supported by the water in the bottom cup. And now I will carefully push the top cup to one side, and we will see what happens. So as you can see, although a little bit of water came out when I first moved the cup, right now our cups there's a space in between the 2 cups and no water is coming out of it. What is supporting this water in the cup? It doesn't look like anything, but that's not true actually. Within the water are molecules which are attracting each other when we call this cohesion. The cohesion is strongest at the surface, so it creates what we call surface tension. And this surface tension and the cohesion creates a very strong layer called a membrane. And this membrane is preventing the water from the top cup from coming out of that hole and just spilling everywhere. So it's a pretty strong membrane right now. But there's also another force in addition to the membrane that is keeping the water in the cup, and that's the surrounding air pressure. So let's try in our second experiment to test how strong this membrane is. And I will move the cup over just a few centimeters, and we'll see how much room we can allow for the membrane to stay strong. So our membrane's still holding up. Oh. So as you see, our membrane broke. This is because as I pushed the cup over, more water was weighing the membrane down, and the membrane wasn't strong enough to completely resist gravity. So the membrane broke and the water fell out of the cup. Well, now that we know that the membrane is not completely powerful, let's try to break the membrane in a different way in experiment 3. So once again, I'll submerge both cups into the water. So we have our cups again, and our top water being supported by our bottom. And I'll again move the top cup slightly. So you can see our membrane is still intact because now there's no water coming out. And if I take this straw, I can blow some water into the bottom cup. And this is a lot like wind going past our lake. Will our membrane stay intact if I blow some water into the cup? As you can see, our membrane is breaking. But as I breathe air into the bottom cup, the bubbles come up to the top. And they displace water in the top cup, which pushes against the membrane and causes the membrane to break. So you see again, every time I blow into the cup, the membrane breaks. So what have we learned? First, that water has a cohesive property which is strongest at its surface. Second, that air pressure and surface tension allow water to resist gravity. And third, that water molecules resist separation until cohesion is broken by a stronger force. So the next time you're fishing on a lake, look around at the water bugs around you and remember that they're being supported on the surface of the lake by surface tension. All right, great to see you. See you next time. Bye.